There are many processes involved in the production of IC chips in semiconductor industry to ensure its quality at all times. The focus for this project is the burning process. Before jumping into the burning process, let's watch a short video of how the machine works in real life.
So during the burn-in sorter machine, it is often seen as one operator to one machine. So it actually requires a lot of manpower as it is a direct proportional to the number of machines that a company has. The IC trays are often found as not fully loaded with ICs. This is further confirmed when it only discovered by the next department operators. And thus, this batch of IC chips that were then discovered will then be moved back to the previous department for rework and retest. This is a hindrance to the production line because every day there is a schedule to be met and the number of IC chips to be tested. Little time will be spared to retest and carry out rework. Thus, this is actually a problem. Many a times, operators are seen to go back to machines unnecessarily, and one of the biggest factor for the false alarm to happen will be the IC presence in the. Even though there is machine visions incorporated in each of the burn-in sorter machines, however, there are times where the machine visions could be blurred or they may be showing false presence of the ICs on the monitor screen. Which is why the team's project is to enhance the machine vision to the next level so that the IC can be detected at a higher accurate level.
Before we explain about our product, let's watch a short clip about the daily lives of an operator in the factory.
Hello? Machine spoiled? Không biết không? Không phải không? Hey, why no IC? There should be IC chips on the tray. Why are all these no ICs? Hey, why? Hey, this is so bad, man. This machine is like every 5 minutes no IC one lor. Like I don't need to go lunch already lor. I don't care. I need to go back to my lunch. I don't care. Just give me my chocolate bread.
So now let's jump back to our IC fault detector. The components used for this product is the LDR, RGB, ESP8266 and the load cell. Some of the applications used to create the user interface for this product are ThinkSpeak, Thunkable, Pushbullet, and the pushing box. For the making of the prototype, we started from the idea of wanting to incorporate all breadboard and the components together. Cuts were made to make space for components like the load cell and the RGB. The design is such a way that the LDR is able to detect IC chips based on light intensity level, while the IC chips were being loaded onto the IC tray and weighed by the load cell. The prototypes were 3D printed and then finally integrated with the individual components. For this project, each IC tray is simplified to just carry 2 IC chips. 2 RGB were used to indicate the presence of each IC chip. The load cell weighs them to double confirm their presence. Each LDR were placed underneath to detect IC chips based on light intensity level. Some of the features of this IoT implementation includes data collection for analysis and can help schedule for early maintenance for the machines. The product is able to alert operators for fault and reduces the chances for false alarm. In this project, we use 2 ESP8266 modules for each LDR sensor. On the right side is the schematic diagram for LDR1, RGB1, and the load cell. On the right side is the schematic diagram for LDR2 and RGB2. So with this product, we are able to detect the presence of IC chips more accurately than before and reduces the chances for false alarm. With the Tankable mobile app, operators are able to look at the graphs from ThinkSpeak to see real-time sensor values of the LDRs and the load cell anywhere and anytime. This means that they are able to focus on other tasks as they need not watch over the machines from now on. Hence, they are able to meet higher productivity targets. So now let's watch a short clip for a demo of the outcome. When everything is working fine, each RGB will turn green to indicate the presence of their respective IC chip, and the load cell value will be more than 0.2 as a double confirmation. When one of the IC chips is missing after the 20-second intervals for standby, a push bullet notification will be sent. If the operator do not know how to solve the issue, he or she can call for an engineer for help through the Tankable app.
Oh, that's an error at machine 1. Again. Okay, so I need to click this. I need to go and fix the machine. This machine cannot be fixed lah. I need to call the engineer. It's so difficult. Useless machine. Find the machine.
Ten minutes later.
A notification regarding the error with the machine.
Yeah, this machine I cannot even understand what it's doing. Like,
Let me
it
check
can
the
only
echo and
yeah.
see what's wrong with it.
Yeah, please do.
Okay, so from the graph on the app, we can see that the LED2 is at state 3, meaning that there's an empty slot.
Oh. Then like that how to solve? I cannot solve leh. I only see got notification on the phone to tell me got error lor, but I don't know how to do. You do lah.
Okay, can.
Now you see keep sending, but I also don't know how to solve. Like thankfully who invented this you can see from your office, right?
Yeah, it's a very good app.
Yeah.
So now let me put 2 IC chips on it. Okay, troubleshooting is done. Let me accept this button. Troubleshooting job complete. Success.
The Tankable app is able to see the number of IC chips present by checking to see if the LDR and the load cell values tally or not. The load cell value is 0.25 over here, meaning there is more than one IC chip present. Other than calling for the engineer for help, the app can be used to decline the troubleshooting job and ask other colleagues for help.
It's lunchtime already. I can't do this. I'll get another operator then.
Hey, I received a notification in your lunch break.
Yes, that's right. Bye.
Okay. So in conclusion, some of the future work that is possible includes implementing an independent light source in a future dark room with dim or no ambient light, and of course a trial test of implementing our product into a real-life burn-in sorter machine.